Friends, today's video is going to be on a TinyML experiment. This is a small product which we have developed, which we call it AI motion detector. You can also call it an XYZ movement detector. So what it is going to do is, like, it has got an accelerometer sensor. You know, the accelerometer sensor is nothing but a sensor which measures the speed, and it can measure the speed in three directions: X, Y and Z. As you can see on the screen, when you do XYZ movement, let's say this is the X sensor, the data varies like this, the pattern varies like this, and let's say Y, the red one is the pattern, and Z, and this is the pattern. Let's say these three signals are simultaneously coming into the neural network, and if you can predict then and there, it is called auto machine learning, auto ML, that means continuous inferencing. Then what happens, suppose you take a window of 1 second. 1 second is nothing but 1000 millisecond. Every 1000 millisecond it will sample for each signal 100 data. That means 10 millisecond each sample. So you can say, in essence, from 3 sensors you get 3 different 100 data. That means 300 data, and these are time stamped data of 10 millisecond separated, and this goes into a neural network which is implemented inside a microcontroller, and that is what we call the AI motion detector. So it can detect up direction or back and forth directions, or rolling movements, wave movements, multiple movements it can create. And this is the basis of the airbag in the car. When it gets hit, a particular pattern gets detected. They may not use the AI technique, but it can be done in AI technique to detect a specific pattern during a collision. So we'll continue with the technical implementation of this next. See, right now is an XYZ AI motion detector. You can see no movement is coming. That is the result of the inferencing. So to start sampling, right now it is sampling the sensor and no movement is happening. And now if it starts moving, sample it. See, it did back and forth, because all 3 sensors produce pattern for back and forth. Now this is sideways, it is detected. Now wave has been detected. This is like a vehicle hits, then the airbags produce a wave, then up and down. So this is a multi-class, this is an example of a multi-class problem. And see, this is the diagram of the hardware inside. There is a VO terminal actually, which is a microcontroller with a display, and there's a battery which powers into this, and accelerometer is part of this inside actually, and accelerometer is part of this microcontroller itself, and the data is going into a neural network which has been created through edgeimpulse and Arduino. That will be discussed now, how edgeimpulse project can be created for this, and also the Arduino deployment. So the project is created using a tool called edgeimpulse. Edgeimpulse can create neural networks. So edgeimpulse is going to create a library, a source file in C++, which will be read by Arduino. So what this edge impulse does is, like, first we have to collect the data through the tab called the data acquisition, where we have just moved the movement detector several times. So hundreds of samples are created. So one of the samples, if you want to see wave, whenever we made the wave movement, that is what we labeled accordingly. So we have created, so you can see that the wave signals looks like that. The pattern remains almost similar for for the wave, different kind of waves patterns are made together. We have labeled it as wave pattern. So similarly, you can see what is a back and forth pattern which looks different. And then we have also created the up down pattern, that is another class. Then we have the rolling pattern which looks like this. So you can see the sideways movement looks like that. So these are different kind of classes which we have created, and at last no movement also you have to create. When there is no movement, this is how it looks like that. The signal, all these three signals from XYZ accelerometers are sampled at a 10 millisecond interval, and total 5 seconds of data is created. So out of 5 second data set, you can see that each 10 millisecond, that means 100 samples per second, the 500 samples will be there from each sensor, which goes into a time series data set into the neural engine. And this edge impulse creates the neural network going through multiple processes. First, it is called data pre-processing. That means you select the window size, which is equal to 1000 millisecond, and and after that you pass through the filters. Actually, in this particular case, we have passed through a filter which is a DSP filter. This is a pre-processing, and this we go through a low pass filter. That is what you can see here, with a cutoff frequency of 3 Hz. So to clean the signal, then finally you go through a classifier, and classifier creates the neural network after training. So training sample cycles we have selected 70, and learning rate is very less, 0.0005, and you train it, and finally training you are getting, see, an accuracy of 100%, 99%, 77%, 97%, etc., which is far beyond better. So after that, just if you want, you can do a live classification using this model, where you can connect the sensor and lively you can test the system. Right now we are not connected to the device. I am just showing you this. And at last we go into the deployment section. That is where we will select Arduino library and deploy into create an Arduino library out of this, and is going to infer in very low milliseconds. You can see 6 to 5 latency is 5 milliseconds, 6 milliseconds, etc. And you say build, look, create a group of zip files which you can unbundle it, unzip it, and you can create a Arduino file which looks like that. It's an Arduino file which can be run by the Arduino program. In this you can see that the entire inference has come here. So Arduino has got 2 sections. So one is setup part, other is the loop part. Loop continuously executes, setup once executes, and you see that actually we are inferring every 2 seconds, and the entire data goes into this is the inferring section. That means the entire frame of data which goes into this, and is these are the lines which are responsible for getting the output. The result comes here. Result dot classification, classification 0, classification 1, classification 2, classification 3, classification 4, etc. like side or up down or no movement, like that. Each are different classifications. And if the classification anything wins above 0.5 probability, that wins the race. So the value, if you look at result dot classification 0 dot value, if it is, that means it may be a no movement or something. If it is greater than 0.5, it is detecting as no movement. You can see that actually here we have put condition 0.7 is the condition we have put for each. If it is going above that, it is firing and it will display movement, roll, side, etc. on the screen. So that's it about the edge impulse and the Arduino program. So we created this particular project.